This simulation here replaces all the labs that we couldn't do in school. And it's really important that you play with this one. It's simple and it will really get across a difficult concept to grasp just using programs like Desmos. Well, Desmos can't even do this. Okay, you need to play with this to get an idea. What this allows you to do is simulate a wave on a string. And with correct timing, you can get it to behave the way you know strings work. We're going to start with fixed end, but you can even do it where the end is loose. And this is about the best simulator I have ever found in years of trying in terms of trying to understand how a string works and how the waves work. So if I set the tension really low here, we can do this. And we can create a wave pulse. Now watch what happens when it reflects. This is a proper simulation. The wave flipped upside down. Did you see that? And if you try this in real life, you'll see that. Okay, we'll let it die off and I'll show you again. I'll make one violent pulse. Watch what it'll do. When the pulse reaches the end, it will invert itself. It turns upside down and comes back. You can verify that this happens. Damping means the wave shrinks. It loses strength due to internal friction. Without damping, you don't see that. If you put in severe damping like this, then the wave dies out on you. You see how it's disappearing over time. So we generally want the damping fairly low. Now, this is hard to do manually, so you can set it up so it works on its own. So we're going to set it to oscillate, and now it's going to give us a frequency. And this really convinces you the idea that it's a circular wave. Okay? And the waves are starting to do this funny thing, where it almost looks like they're going to stand still. So it's really mimicking real life quite nicely. And what we're going to do here is we're going to swing this frequency down really slow and bring the amplitude down. So I'm going to bring the height down so the wave is very low in height, and then I'm going to set the frequency down really low. Now the wave's dying out, so I'm going to crank up the damping, and that'll kill that leftover wave. And then I'll run the damping back down again, so we'll see these slow pulses moving along. And slowly, without any dampening, the pulse is reinforcing itself. Bit at a time, we're seeing the pulse get stronger and stronger and stronger. I'm going to bring a ruler in here. Okay, and what we're looking for is what's called the standing wave. Do you see this green dot? If we found a standing wave, one of those spots should stay still and not move. And the peak and trough here should also stay put, and it's not. It's slowly drifting. I'm going to boost the amplitude just a little bit here. Okay, and I'm going to notch my frequency up a bit. I'm going to go a little bit higher here. I'm looking for a point where I can make a stable wave. Now for a brief moment, run the damping up so you crush what was left of the prior wave, and then you can swing it down. You can also hit restart. But if the damping is set really low, then it's going to echo back and forth for eternity. Now we're starting to see this growth of a repetitive wave. And this is called a standing wave. And it's only a standing wave if the green dot stays where it is, and this area right here, see up, down, is it staying put in the same spot, or is it drifting? And it looks to me like it's drifting. So I'm going to kick the amplitude up just a little bit. I want the wave a bit bigger. You got to be careful. If you make the amplitude crazy high, it gets distorted. And I want to see if I can stop that wave. So I'm going to play around with different speeds. I'm going to add a little bit of damping so it doesn't echo and bounce around a lot. So you'll see it's take a moment for the wave to stabilize. and I'll just try again. I'll go to a higher frequency. I'm going to set the dampening quite high till I can locate it. I'll boost the amplitude. There we go. Now we're making some good waves. They're moving along through there. What happens if I set the tension high? Ah, that's better. Okay. But the dampening, the wave isn't making the far side. So I'm going to crank the dampening back. There we go. Okay. That wave isn't standing still. Let's play around here and see if we can find a spot where we can get the exact same repetition. Let's find it here. I'll show you what I mean. You'll know when you found it. The wave will no longer look like it's moving. It'll look like it's standing still. Now you see the peaks are still moving. I'll move my dampening up a little bit. With a little care, we can stop it. Is that looking like it's staying put there? I don't know. Now I'm going to dial my amplitude down. The high ups and downs can really interfere with it and cut the dampening right out. And you'll know you found the spot. Maybe. Look at that. Is the green dot staying put or is it drifting left and right? If we look right here, that up and down is staying still. The area of up, down, up, down, up, down is staying still. And you see this red dot right there? It's not moving left to right at all. We've formed a standing wave. The reflection is coming back at the same moment and the wave is canceling. Now it's not perfect because you see this red dot right there. For a while it settles down on the dotted line, but then it starts to bounce a little bit. And if you can nail the correct frequency, that little red spot, see the whole wave is dying out? That shouldn't happen. It's temporarily canceling and then it reinforces. If you nail the correct frequency, then it will remain up and down, up and down, up and down like this. And we should find it at half that. 1.03 should find us the other one. Give it a few seconds to stabilize. You can run the dampening up to crunch it down, bring the dampening down, and we should start to see a stable waveform. But you see it's not quite doing it. It starts and then it dies off. So we got to creep around looking for a spot where that doesn't happen. So I'll kick the amplitude up for a little bit here. See if we can find that spot. We want to get some part of the wave to just sit like an axle on the line. I think last time it was around here. But if you're very careful, you can nail it. Where there's a spot that's just going to sit still on this dotted line. But you really have to play to find it. So I want you to try that till you can get the wave standing still, where it's just bouncing up and down, but there's no more movement left or right on it. Okay? Have fun until you're dizzy.